Thank you for joining me for more calculus review. And today we're going to be working with an integral, and we're going to find the definite integral from 0 to 1 of x squared e to the x dx. Now, in order to find this integral, I'm going to start off by trying to find an antiderivative. So I'm actually going to answer the related question: what is the indefinite integral of x squared e to the x dx? And at the end, after I find that, I'll come back to my original question and find the integral from 0 to 1. So in that way, what I'm going to do is I'm going to start off the same way I have been doing with all of my integrals, and I'm going to say, can I guess what the answer is going to be? If I know the antiderivative, I can write it down, I can check the answer, and I can use it. However, in this case, I don't know what the answer is going to be, so I'm going to move on to my next technique of integration, and I'm going to ask, is there an inside function here? Well, if I look at this, the only thing that's inside of anything else is x. But if I try to substitute x equals I, it's not going to change anything other than the letter. So it's not going to make my integral any easier. So I'm going to say, no, there is no inside function. After that, I'm going to ask, is this a product of functions? And indeed it is. It is x squared times e to the x. So I do indeed have a product of functions. Now, is it a product of two trig functions? And no, it's not. There are no trig functions here, so I'm not going to try to use my reduction formulas. So instead I'm going to move on and say, well, it's a product of functions, they're not trig functions, so we're going to try to use integration by parts. So now, in order to use integration by parts, I first want to remind myself of the formula that we're going to use, and what we're going to have is the integral of first d second is equal to the first times the second minus the integral of second d first. So therefore, if I want to use my integration by parts, I need to find a first function, I need to find a second function, and then I need to find the derivative of the first in the integral of the second. And so what I have is my first function, my second prime, my first prime, and my second, and I'm going to write those out. Now, if I look at this, I really have two options for first and second prime, and so I have x squared and e to the x. Now, if I pick one of these, I'm going to pick one as the first and one as the second. The thing is that I have to be able to integrate the second prime. So whichever one of these I call second prime, I'm going to have to integrate. In this case, I can integrate x squared and I can integrate e to the x. So in both cases, I could choose actually either one to be my second prime. The next thing when choosing is I want to think, well, let's try to make things easier on ourselves. So if I take first is x squared, the derivative of x squared is 2x, so it seems to get that the derivative is a little less complicated. Whereas if I take e to the x, the derivative is e to the x, or the integral is e to the x, and so in either direction the difficulty doesn't change. So actually here I'm going to decide that the first function is x squared, and my second prime is e to the x. Now if you're trying to choose between the first and the second prime and you pick the wrong ones, just run with it, do integration by parts. You'll notice that you'll end up with a more complicated integral, and so you could go back and start the process over again, and so next time around you just pick a different first and second prime. Alright, with that then, what is the derivative of x squared? Well, that's 2x. What is the derivative of e to the x, or what is the integral of e to the x? Is e to the x. And so what I get is my first, my second prime, my first prime, and my second prime are all right here. And so in order to find this, I'm going to fill that into my formula. I'm going to get first is x squared times the second is e to the x minus the integral of the second is e to the x times the derivative of the first is 2x dx. So now from there, I'm just going to simplify this, and I'm going to get x squared e to the x, and I can factor out the 2, so minus 2 times the integral of x times e to the x dx. And I do want to check now, I ended up with a new integral. Is this new integral more or less complicated than my original? Well, we noticed that we still have an x times e to the x instead of an x squared e to the x. But because x is a lower power than x squared, we would think, yes, we probably made some progress here. So that means that we keep our answer, and then we start over with looking at just this integral. Alright, so I've gotten rid of some things, so I have some more room, and I just have my original integral is x squared e to the x minus 2x e to the x dx. So then I want to find what is the integral of x e to the x dx. And so in order to do that, I'm going to start over with my processes. Can I guess the answer? In this case, I'm going to say no. Is there an inside function? No, there is not. So if I move on, I would say, is this a product of functions? And yes, it is. Is it a product of trig functions? No, it's not. So therefore, I'm going to try, again, integration by parts. And so I'm going to have to set this up as I did before with a first, a second prime, a first prime, and a second. And I'm going to have to recall that the integral of first d second is first times second minus the integral of second d first. And so I'm writing that down so I have that so that I can just use that to plug in as I go once I have my first and second and first prime. With that said, I have to pick a first and a second function, so my options are x and e to the x. Now, what I want to do is I noticed that I've already done one integration by parts, so the first time I picked x squared as my first. So if I switch these up now, I'm going to undo what I did. So I want to make sure that the first function is now x because I picked the polynomial the first time for the first, so I should pick the polynomial the second time for the first. Now, our second prime is again going to be e to the x because I don't want to switch that up. And so if I continue with that, the derivative of x is 1, the integral of e to the x is e to the x. And so what I end up with here is the integral of x e to the x is the first times the second, so x e to the x, minus the integral of the second times the derivative of the first is 1 dx. And so now I'm left with a new integral, and I ask, is this integral easier than this one? Well, this is just e to the x dx, which is easier than x e to the x dx. So we have again made progress, but we're going to start over and say, can I find this integral? Well, can you guess the answer of e to the x dx? Well, the integral of e to the x dx is just e to the x. And so what I get is x e to the x minus e to the x. And now, because I finished an integral, I need a constant of integration out here, so I'm going to say plus c. So the integral of x e to the x is x e to the x minus e to the x plus c. Now that we've found the integral of x e to the x dx, all I'm going to do is substitute that integral in here. So I'm taking the answer from before and substituting it in. And so I realize that the integral of x squared e to the x dx is x squared e to the x minus 2 times x e to the x minus e to the x. And then we had, for the integral of this portion, we had a plus c in there. We don't need the plus c every single time, we just need to make sure that we have a plus c at the end of the integral. So what I did is I found the integral, and then because I'm finding the antiderivative at the very end, I add in a plus c. So I get that the integral of x squared e to the x is x squared e to the x minus 2 times x e to the x minus e to the x plus c. Now recall that this was the antiderivative, but my original question was a definite integral. So what we have to do now is we have to use that answer to find the answer to our definite integral. Alright, so we've looked at our original definite integral was the integral from 0 to 1 of x squared e to the x dx. We found all antiderivatives, so here we've just chosen one, was the x squared e to the x minus 2 x e to the x minus e to the x. And then I just want to evaluate from 0 to 1, so that means I'm going to plug in 1 and then subtract off plugging in 0. So if I plug in 1, I get 1 times e to the 1 is e, minus 2 times 1 times e to the 1 is e to the 1, minus e to the 1. And then I subtract off plugging in 0, and so if I plug in 0, I get minus 0 minus 2 times 0 minus e to the 0 is minus 1. So now, as long as I'm careful with all those parentheses there, what I end up with is an e here. E minus e is just 0, so negative 2 times 0 is 0. Minus 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 is a negative, and then I get 2 times 1, so I get e minus 2. So the definite integral, or the area under the curve of the function on the given interval, is going to be exactly e minus 2. Thank you for watching. There are more resources available in the description below if you'd like to follow the links. You can also check out more videos available in the playlist. Please subscribe, and if you know anybody else who would benefit from watching these and get some help in calculus, make sure to share the video with them.